Okay, so we are on section 3, topic 3. So what we started already, piecewise functions, was kind of an intro. And so this section's focusing more on the graphing and the writing of piecewise functions. And hold on, let me just switch that light, see if I can get this to show up a little better. To graph piecewise defined functions, graph each piece of the function on the same coordinate plane. Domain restrictions must be considered when graphing each piece. So we already knew that. Domain restrictions must be considered when graphing each piece. Graph the following piecewise defined functions. Okay, we even had this in homework, okay? So this is not new. Again, it's just focusing more on the graphing instead of an overview. So we have f of x equals x squared plus 2 and f of x equals x cubed. So we know if it's the highest degree is 2, that's going to be what? Quadratic, a piece of a quadratic function. Not the whole thing though, only when x is less than 1. And x cubed, what's that? Do y'all know what it's called? I haven't dealt with the cubed much. It's called a cubic function, okay? Nothing is straight except for a line. So when we graph this, it's almost going to kind of look like a line, but you want to make sure you got some curve in it because it's not straight. If it was straight, it would be linear. Okay, so let's look at f of x equals x squared plus 2. We're going to graph it when x is less than 1. So I'll make a little table of values. And I will start with 1, but it'll be an open circle, okay, because it's less than 1, does not include 1. And I'll choose values that are less than 1. Maybe -1, or I'm sorry, let's start with 0, then -1, -2. And if I need more, then I can always pick more. So let's just substitute it in. 1 squared is 1, and 1 plus 2 is 3. When x is 0, 0 squared is 0. 0 plus 2 is 2. When x is -1, -1 quantity squared, that means -1 times -1 is +1 plus 2 is 3. -2 quantity squared is 4, and 4 plus 2 is 6. So let me go ahead and graph those ordered pairs and then see if I need to find more. So when x is 1, y is 3. It does not include this point, so it's an open circle, right? Because it does not have the or equal to part. When x is 0, y is 2. When x is -1, y is 3. When x is -2, y is 6. I could find more points if I want, but I know this is a quadratic, and I already see where the vertex is and the curve, so I can put an arrow on the left side because values that are less than 1, that would go all the way to -infinity. Everybody cool with that? If you were not here last class, we used these notes. I did make a video, I think in another class, but also it goes right along with Algebra Nation. These notes are from Algebra Nation, and if you watch Amy, she goes pretty slow in explaining it. She doesn't just speed right through it. So if you weren't here, or if you're still confused from my lesson, I would definitely go watch Amy on Algebra Nation, okay? All right, now we have to graph x cubed when x is greater than or equal to 1. So let me pick some values of x. I'll definitely use 1, 2, 3. See where we get. So when x is 1, 1 cubed is 1. When x is 2, 2 cubed is 8. When x is 3, 3 cubed is 27. And that's already off my graph, so I'll just start there. So 1 comma 1, that's a closed circle because x is less than or equal to 1. 2 comma 8. And then 3 comma 27 is way up here. Now I know because that is so steep, it looks like it might be a straight line. But it's not because it's cubed, okay? Only time you have a straight line is if your highest degree is a 1. So it's going to be hard to put some curve in there because it's so steep, but try to put a little curve. Definitely don't use a straight edge. Okay, if it was a little more compressed, it would be easier to see that it was a curve, but it's not. But you know it's not a line. Everybody cool so far? Okay, let's answer some questions about this graph. What is the domain of the function? So your domain is all possible x values. What would your domain be? All real numbers. There's no value. We have arrows going to the left to negative infinity on the x-axis. We have arrows going to the right. And then also right here, when x is 1, it's not included in this function, but it is included in this one. So definitely all real numbers. It's going to be a lot of flipping back and forth on this one. So we could say all real numbers. You could use that little symbol that means all real numbers. Or we could get real fancy and say x such that x is an element of all real numbers. Or you could say negative infinity to positive infinity as well. Of course, if this was your homework, you don't have to write all of those down. I just want you to be familiar with all the different ways you could see it. What is the range of the function? What is the range of the function? Is that going to be all real numbers? What is that going to be? Just 1? Greater than or equal to 1, because you have a y value that is actually 1, and everything above that, we have points on our graph that correspond with every y value above 1 and equal to 1. So yeah, it would be y such that y is greater than or equal to 1. Or you could say an interval notation with a bracket 1 to positive infinity, parenthesis. C, what, if any, are the x-intercepts of the function? What, if any, are the, bless you, x-intercepts? That was a y-intercept. Do we have any? No, there are none. So I'll flip back over in a minute and write that, but let's look at part D. What, if any, is the y-intercept of the function? That's it, right? So when x is 0, y is 2. So there were no x-intercepts. And the y-intercept when x is 0, y is 2. Then it wants to know over what interval is the function increasing and also decreasing. Okay, do I have any increasing intervals? Yes. From what to what? From 1 to positive infinity, is that it? That is an increasing interval. Right. And also from 2 to 1, it's also increasing, correct? So you have to include both of those. So it is increasing from, actually, because here it's increasing and here it's increasing, and so it doesn't start and decrease again, right? We could just list this together. We could say from 0 to positive infinity is increasing, because those, even though they're two different functions, they're increasing and they have the same x values. Does that make sense? So we could just lump those together and say from 0 to positive infinity it's increasing. If you listed them separately, I would not count that wrong, but if it was a multiple choice, you would probably only see from 0 to infinity. And again, at 0 I use a parenthesis because at 0 it's not doing anything. That's its starting point. If I wrote it the other way, let me look at the graph while I do it. I would say from 2 to 1, and they would both have parentheses, and then I would say from 1 to positive infinity. You see how they both share that end point and beginning point, so they just put it all together. I'm sorry, I said 2 to 1. I meant 0 to 1. And then it was decreasing from where? Negative infinity to 0, it was decreasing. Very good. Negative infinity to 0. And I do have the...
Excuse me?
Yes?
Do you have Patience Alexander?
I do.
Could you send her this one, please?
Sure.
Thank you.
You're welcome. Yeah. What, if any, are the relative maximums of the graph? Relative maximums of the graph. What, if any? Do we have any? Well, what do you think they are? There aren't any, because these arrows go up to infinity, so we don't count that as a maximum. And remember, a maximum is when your graph is increasing and then it reaches a high point and then it starts decreasing. That's a maximum. Do we have any? No. Do we have any minimums? What? Exactly, right here. A minimum is where your graph is decreasing and then it gets to a low point and then it starts increasing again. So we don't have any relative maximums, but we do have a relative minimum. So F is none, and G is the ordered pair 0, 2. Is the function considered to be continuous? No, it's not. And it said why? So the way I explained it to y'all is, if you take your pencil from one side of the function to the other, if it's continuous, there won't be any jumps to get to the next function, right? But obviously we have jumps. The technical reason would be because as x approaches from the left or the right, the function approaches different points. So as your functions are coming to meet each other, this function is approaching 4 on the y-axis. This function is approaching 1 on the y-axis. They're not going to the same place and including that point. Okay, so this time let's write down the technical reason. So I said no because x approaches from the left or right I should say when x approaches from the left or the right. The function approaches different y values. Everybody cool with that? Okay, I want you to look at the try it on the right side of the page. And I want you to try it. If you get it wrong, we can erase it. Put what you think you're supposed to put. Last. So we have three pieces of this function here. 3x minus 2 when x is less than 2. What kind of function is that? Linear, right? So it's going to be a part of a line. What kind of function is this? It's just a point on the line, right? 2, 3. It's just an ordered pair, that's all. What kind of function is x squared? Quadratic, when x is greater than 2. So I'll start with the top piece, find values when x is less than 2. I'll start with 2, that'll be my starting point. And less than 2, it's a line, I only need 2 points, but gotta be extra sometimes. So 3 times 2 is 6, 6 minus 2 is 4. 3 times 1 is 3, 3 minus 2 is 1. 0, 3 times 0 is 0, 0 minus 2 is negative 2. So when x is 2, y is 4, and that is open circle because it's less than 2, not including 2. 1 comma 1, 0 comma negative 2. So only graph the left side, and I will put an arrow on the left side because it's all x values less than 2. Okay? When x is 2, y is 3. When x is 2, y is 3. And that will just have one closed circle because x equals 2. It includes 2. And then for my quadratic function, that's for values of x that are greater than 2. So I'm still going to include 2 because it's a starting point. It's a quadratic. I'll do 2, 3, and 4 and see what I have. So when x is 2, 2 squared is 4. When x is 3, 3 squared is 9. When x is 4, 4 squared is 16. So I'm getting off my graph. So 2 comma 4. And does it include that value of x? No. And so there's already a point there, right? And it's already open. So we just still have another open circle in the same place, okay? 3 comma 9. 4 comma 16, which is off my graph. Again, that's very steep, so it's hard to make it look like a curve, but it is not a straight line. So try to get some curve in there as best as you can. It's hard when it's steep. Ah, I did. Thank you. It's supposed to be connected to the open circle. I did that when I was making my own notes too. Thank you for pointing that out. A little easier to make it a curve when it goes to that point. Okay, what is the domain of the function? All real numbers. There's no x value that you will not find some ordered pair on the graph, even when x is 2, because if we did not have this ordered pair here, it would be all real numbers except for 2. But because we had this extra little ordered pair down here and it does have an x value of 2, it is all real numbers. So I'm going to say x such that x is an element of all real numbers. Or you could say negative infinity to positive infinity, or you could write out all real numbers, or just the symbol for all real numbers is fine. What is the domain of the function? Or I'm sorry, what is the range of the function? Except for what? 4. Except for 4. All real numbers except for 4. Or we could say excluding 4. Excluding y equals 4. Yep. Because this ordered pair right here, there's no y value on this graph. No point on the graph that has a y value of 4. Okay? Because that's open. Is the function continuous? Not so much. Big no on that one. Julio? Alright, anybody have questions before we go on to section 3, topic 4, which is more graphing and writing piecewise defined functions. It's a part 2. This one was really fast. Oh, is there a beat the test on that? Oh, got the wrong part. Actually, I will start that on a second video. I'll be back. Maybe.